welcome back to the online tutor once again. So in this video I'm going to discuss about the quadratic functions, right? And the quadratic function is in your grade 12 second term lesson, right? So let's move to the uh, lesson, right? In the quadratic function, the main formula is ax squared plus bx plus c. I think already you all know that. Alright, so then actually this is quadratic function, then I'm put fx, right? This is fx, right? Fx equal ax square. Actually here a, b, c all are real numbers, any real numbers, right? Then what I'm going to do now, I'm just taking a out and making it like b over ax, c over a out, use the completing square method, minus b squared over 4 squared, x plus b over 2a square, take a common denominator, 4az, 4a square, and simplify it. So a times 4az minus b squared over 4a. This is my quadratic function. Right now here, so what happened, this a, right? So this a can be either, this can be either, it can be greater than 0 or less than 0. If it is greater than 0, we know as the function is minimum. If it is less than 0, the function is maximum. So afterward, so what is this? This is minimum or maximum value. Minimum or maximum value. Minimum or maximum value. Right? So what is this? This is symmetric line formula. Symmetric line. Right? So if you sketch the graph, right, then if it is like this way, this is the symmetric line. Right? Then it's equal, x equal minus b over 2a. So this is a minimum value. Then minimum or maximum, it's 4az. 4a. So it can be either maximum, right? So symmetric line and this minimum value. Minimum or maximum value, right? So this is my quadratic functions main idea, right? So then after I'm going to explain a counter example. So just assume if you have a function, example number 1, x squared minus 4x minus 1. So I'm going to complete the square. Whole thing is square minus 1 minus 4. Okay, so then this function is minimum function. Symmetric line, x equal to minimum value minus 5. Coordinate plus 2 minus 5. So then, how to draw it? So how to draw it? Y-axis, x equal to, right this way, minus 5 over here, right? And this way, right? So the roots mean fx equals 0, then x minus 2 whole thing square equal 5, plus 2 minus root 5 plus 2. So root 5 mean more than 2, therefore this is minus root 5 plus 2, minus root 5 minus 2. So plus 2, plus root 5 plus 2. This is my function fx. Let's look at a second example. Fx equal minus x squared plus 5x try to draw it. So you should take minus out. X minus 5 by 2 square, 25 over 4. 29 over 4 and multiplied it. So then this is maximum function. And symmetric line, x equal 5 by 2. Maximum value 29 over 4. Coordinate, which is 5 by 2, 29 over 4. So then let's draw it. It's 5 by 2, right? 29 over 4. So then this is my graph, right? So if you want to find these two, you should equal fx as 0. Over 4. Then it's 29 over 2 plus 5 by 2, 29 over 2, 5 by 2. These are the values of roots now. So this is my maximum function. Okay, now I'm going to discuss about roots. So how to evaluate roots? So can you remember this equation? X equal minus b plus 4 minus b squared minus 4ac over 2a, right? This is known as a root equation. So here this b squared minus 4 is it's known as discriminant, delta. Right, so discriminant. Discriminant, right? So discriminant mean which is held to, right? So delta over 2. You should memorize this word, right? So the discriminant is held to evaluate, to help to discuss about the roots, right? So behavior of the roots actually. So actually in discriminant has 3 life cycles. One is discriminant can be greater than 0. It can be less than 0. It can be equal 0 and less than 0. Right? So discriminant can be these all 3 ways, right? So if discriminant is greater than 0, inside the square is positive. So then roots are real. If discriminant is equal 0, then roots are real and coincident. So here roots are real and distinct. So here roots are non-real. Roots are non-real actually. So these are the 3 life cycle of the discriminant, right? So the discriminant has 3 life cycles. It can be greater than 0, it can be equal 0, it can be less than 0. If it is less than 0, the roots are non-real. If it is equal 0, the roots are real and coincident, right? So then other one roots are real and discrete. So afterward I will discuss this with a suitable graphs. Okay, now I divide my board into 2 parts, right? So first part is a greater than 0, other one is a less than 0. Right? So what happening if a greater than 0, the functions are minimums, right? So according to that I am drawing 3 graphs. So a less than side, another 3 graphs. So here a greater than 0 functions can be like this way. It can be touching x-axis or not touching x-axis. So other one, the functions can be cutting x-axis, touching x-axis and not touching x-axis anymore. Right? Then these 3 graphs are discussing 3 different situations. So here this is my minimum graphs, maximum graph. So here a greater than 0 first graph, discriminant is greater than 0. Here discriminant is equal 0, less than 0. So you can see this function doesn't have any real roots. It's not touching x-axis exactly. So then no real roots. Here exactly one coincident roots, x equal minus b over 2a. So that is the coincident roots. This is cutting 2 different values. So then these are my quadratic functions, right? So quadratic minimum 3 different graphs, right? So here it's again distinct. Discriminant is greater than 0. Here equal 0, less than 0. Right? So these are the behaviors of the discriminant actually one more important thing, right? In this scenario, the function y equal fx, right? If it is y equal fx, then function is always positive. Function is always positive. But here, the y equal fx, the function is always negative. The function is always negative. And after, these roots are real. Roots non-real. So here also roots are real. Non-real. Roots are non-real. Okay, this is my first example. Fx equal x squared plus 3px plus p. Find the interval of p for fx greater than 0. So how to do these kind of situations? So here, this is my px. The function greater than 0 means the function is going up, right? So then discriminant should be greater than 0, less than 0. What is discriminant? Which is b squared minus 4ac, right? Here ax squared plus bx plus c. So a mean 1, 3p, c mean p. Discriminant 3p whole thing is square, 4, 1, p, 9p squared, 4p. This is my discriminant, right? So discriminant less than 0. So p out. So then after, I'm going to draw the p-axis. This is 0. This is 4 over 9. So if you put 0 less than 0 something, then negative, 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 it's positive. In between these two, so you can put 0.1, 0.1, positive, negative, it's positive. So then less than 0 means p is always greater than 0, less than 4 over 9. Okay, this is my next example. The fx is given 5x squared minus 10x plus k. Find the value of k for fx greater than 0. So how to do this kind of? So here fx greater than 0, 2, right? So fx means 5x squared (10x plus k minus 2), right? So assume this is another function gx. So gx will be greater than 0. Then discriminant is less than 0. So can you remember it again? I am drawing again. This is my gx function, and it's always up, right? So then discriminant means b squared minus 4ac less than 0. What is b? B mean minus 10, a mean 5, c mean k minus 2. This is minus 10 whole thing square into k minus 2 and simplified it. A 5, C mean k minus 2, then it will be 100, 20k, 140, 20k, 7. So this is 7. So this is the values of range of k to determine that inequality fx greater than 2. Okay children, this is my next sum. Fx is defined, right, it's this way, and find the range of k for fx less than 0. So how to do these kind of situations? So actually the fx less than 0 mean, the function is its maximum, right, under the x-axis. So then maximum mean is less than 0, under the x-axis mean discriminant is less than 0, right? So here this is my ax square plus bx plus c. A equal k minus 2, b equal minus 3k, c equal k minus 2, right? So a should be less than 0. A should be less than 0 mean k minus 2 less than 0, k less than 2, and also discriminant less than 0. B square mean my minus 3k square. A mean k minus 2. C mean again k minus 2. It's 9 k square, k minus 2, whole thing square. So now simplify it. 9k square, k square, 4k plus 4 less than 0. 9k square, 4k square, 16k minus 16 less than 0. So then you can simplify it further. It would be 5k square, 6k, 16k, minus 16. So then you can factorize it, minus 16 into 5. 8 into 2, 8 into 10, so when you divide it 2 and multiply it by 2, minus 4 into 20, 5k square plus 20k minus 4k less than 0. So then 5k can be taken out, minus 4k out, 5k minus 4. So after then, this is my k axis, minus 4, 4 over 5. So more than 4 over 5, it's getting positive, negative, positive. In between 0, it's negative and positive. So we need to less than 0, then k is in between this range, and k should be less than 2. So both should be happen. So basically it's like this way, no? And less than 2. Then common region is x minus 4 to 4 over 5 for all real numbers. This is the final answer. So always you have to find if the fx is less than 0, the function should be maximum function, right, which under the x-axis. So under the x-axis means the discriminant is surely less than 0. Okay children, this is my next question. You have to find p for the fx greater than 0. So again, what I'm going to share with you, if the function is greater than 0 means it should be minimum function. Minimum function means a greater than 0 under the x-axis mean discriminant less than 0. So a mean my, right, so a mean my p and b mean my 2p minus 1. A mean p greater than 0. So discriminant mean b square mean square 4az less than 0, 4p minus 2p plus 1 minus 4p. So actually this is 4p, it's 8p. So actually it's not factorized, right? So I'm taking 4p out, right? So separately I am going to factorize it. 4p squared minus 8p plus 1. So you can take 4 out, minus 2p plus 1 over 4, p minus 1 whole thing square minus 1 plus 1 over 4, p minus 1 square minus 3 over 4. So this is p minus 1 square root 3 over 2 whole thing is square, p minus 1 plus root 3 by 2 minus root 3 by 2. So now it's less than 0, right? It's less than 0, less than 0, less than 0. So you can divide all by minus, all by 4. So now I'm going to draw the x-axis, p-axis, right? So p-axis, it's plus 1 minus root 3 by 2. Here plus 1 plus root 3 by 2. So root 3 by 2 means it's 1.7 something divided by, it's surely positive, right? So then it's actually, here it's actually 1 is over here. So when you put 1, right, so this whole thing positive, this is negative. So then this is negative, positive, positive, right? It should be negative, then p range is more than root 3 by 2, less than. So this is the p value, right? So here p is also greater than 0. So actually 0 is over here, no, it's greater than 0, but this is the final answer of p. So to be the function is positive for any value of x, right? So that is the range of p. Okay children, this is my next example. State whether the following equations roots are real, distinct real or non-real. So okay, so can you remember, so in the beginning of the lesson I told you if discriminant is greater than 0, the roots are real and distinct. Equal to 0, roots are coincident. Less than 0 means roots are non-real, right? But if these two both are happening mean roots are, so it's equal or greater than or equal to 0, roots are real, only real, right? So then I'm going to check the discriminant of the each and every one by one answers. This is x squared 7x plus 9, ax squared plus bx plus c equals 0, a equal 1, b equal minus 7, c equal 9. So discriminant for a z, b mean 49, a1, c9, 36 greater than 0. So then roots are real and distinct. It's like this way, right? The function is cutting the x-axis from the two distinct points. Cutting the x-axis from the two distinct positions. Okay, the next one, row number 2. In the second one, it's again b squared minus 4ac. So b mean minus 4 to the power 2. A is 4. C is 1. 16. 16. Right, so then roots are real and coincident. Real and coincident. Okay, what about the third one? The third one, is 21, 2 into 6. It's 8 into 6. Roots real and distinct. Okay, the last example, fourth one. I'm going to simplify it like 4x squared, 4x plus 1, a mean 4, c mean 2, 16, 32 minus 31. So discriminant less than 0, roots are non-real. So actually the graph is like this way. That is why. Okay, this is these 4 corrections, right? So we state the equations are real, distinct or non-real, right? So actually coincident, right? We discussed the real, coincident or the distinct, real, distinct or the non-real. Okay, I think this all three parts are discussed with these 4 examples. Okay children, this is my next example. If fx 3x squared plus 2ax plus b, a, b are real, has real and distinct roots, show that a squared greater than 3b. So how to do this? So actually the fx mean 3x squared 2ax plus b, you know, and it's like ax squared plus bx plus c. So a is like 3, b is like 2a, c is like b. This is b squared minus 4ac. So b square mean 2a square, 4, a mean 3, c mean b. It's 4a square minus 12b. So actually discriminant should be greater than 0 only. So this is to be real. To be real and distinct. So actually easy, right? So you just need to memorize the the summary of the distinct, coincident, non-real part. So the graph, right? So can you remember the graph? So I divided it into 2 categories, and each category we had 3 graph, no, right? So this whole thing is depend on the graph. Actually this function is minimum function. Okay children, so this is the end of the today's session, right? So quadratic function first video tutorial. So in the next videos I will discuss more things, right, about the quadratic functions. So thank you very much for participating and have a nice day, and don't forget to subscribe my YouTube channel.